Welcome to Atlas Press Metals and episode 4 of the PM Blend. I'm Mark. This is Joe.
How you doing? Good to see you again today, Mark.
Yeah, great to see you as well. And we're happy to be back and looking forward to today's episode, Joe, where we're going to talk a little bit about secondary operations.
Sounds good.
And so why don't we...
But it's not secondary to us.
It's not secondary to us.
It's important.
However, it is secondary to that final part
that
we're going to produce.
That is true.
And important to our customers to understand what secondary operations are. And why don't we jump into that, Joe? That'd be the first question I have for you is why don't you explain what are powdered metal secondary operations?
Well, in our process, if you happen to have watched our earlier videos, we talked about compaction, we talked about sintering. Anything after that sintering operation, the industry considers a secondary. So the part comes off of sintering, it has to have some other machining or plating or heat treat or any type of process done to it. That's considered a secondary to our process.
Okay. And why are secondary operations necessary in powdered metal?
Well, we'd love to say we make everything net for the customer, but there are obviously circumstances that we need to do something beyond what that mold and sinter process can provide. Very simple one would be a plating operation for some corrosion protection. That would be a secondary operation to get tossed in. But then you go to the much more complex side of the machining operations that could potentially need to be done. Those all need done. So if somebody needs a side hole or a groove cut in that we can't mold and eject, that secondary operation would be needed in order to provide that customer with his finished part that they want to print. Wouldn't be net for us out of molding, but the customer still wants that.
Okay. So you touched on just briefly machining and plating, but what are some of the other common secondary operations?
Well, obviously the machining side is the largest one because there's the whole myriad of drill tap, the lapping and grinding operations and all of that. So everybody's, I'm assuming, fairly familiar with all the machining operations. But then you get into some that a lot of people don't deal with would be like a knurling operation, or you would get into a post heat treat operation, or some type of other coating that would need to go on other than a zinc plate or something like that. Those operations all exist. Internally, we still also do a lot of sizing in our product and deburring. That is also a secondary that we do most of that inside. There's a handful of things we still send outside, but a lot of that is done in our building. And that's to clean up the edges. In the case of the sizing, it's to tighten up the tolerances on bearings and some structural components that we have a need to do there as well. That's a remnant of our early days of making bearings and spacers. Okay. We still have a fair amount of sizers. In our old video, our previous videos where you kept calling us out on how many, I think we have 10 sizers, but I'm not positive of that. I would have to have Ann go do that count check too.
And maybe Ann could put that up on the bottom of the screen along with the number of presses we have and the number of furnaces we have. So,
but in addition to that, that's the common things that get done from that aspect.
Okay.
But if you want to go through all of them, we could go through all of them.
Well, I think there's some we want to touch on, Joe. And one of them I noticed that seems to be a common page on our website that gets hit is steam treating.
Oh, yes.
So, again, why don't we just kind of briefly give a description of what that is, Joe, what the benefits are to a steam treat?
Well, the steam treat is a oxidation process that's done, and it's basically the name of it kind of gives it away. We load the parts into a basket or onto a belt, depending on which version that we're on, and we have both available to us. They load them into a basket, and they have to make sure that the part is readily available to have a flow of air, for all intents and purposes, through the product. They then go into a heat stage where they ramp that temperature of that part up about 1100 degree neighborhood, give or take.
Okay.
And at that point, they inject superheated water, steam, into that environment. And what that does is it converts the surface of the iron particles to an iron oxide, And it's a specific iron oxide we're looking for. It's not a red rust. It's kind of blackish blue in coloration. And at that point, then when you're done with that, you let it cool back down and ramp and release it from the environment. And you have this nice blue, black, grayish oxidation on the surface. And the nice thing about it is it gives some wear resistance.
Okay.
So you don't necessarily have to heat treat after that. It gives some general corrosion protection. So if you're picking the part up and handling it, it protects it from red rusting in those circumstances. It can actually seal some porosity off, depending on how long we cycle that. And it will do a nice job of that as well to do that. So if you had some hydraulic resistance or you were doing some operation post this steam treat process from a machining standpoint, it wouldn't necessarily absorb the machining fluids and things like that. So that is another one that we do.
Okay. I know another question that seems to come up, or, is we oftentimes try to explain the different coatings or the different plates that we have, plating options we have. But it's important that we explain the resin process prior to that. Do you want to just kind of touch on that as well?
Sure. I kind of alluded to it when I just talked about steam treat doing sealing, but our part, due to the compaction system and the methodology that it's made, it has available porosity in it. As I mentioned, early days were in bronze bearings that naturally had that porosity that we filled with oils. Mm-hmm. And I guess we didn't touch on that one either. So
and we still do oil.
We still do a lot of oil impregnation. Well, that's great in a bearing application. But if I have a structural part that I want to have plating put on it, the first couple of baths in a plating operation are a caustic and rinse baths to strip any oxide layer off of that before it goes into the final plate. Well, those caustics, if I would put a raw part into it, would get absorbed into the porosity of my part. So the way we get around that is we resin seal, or our platers resin seal the product, so that in a conventional plate, it's just a window frame. It's just the outside surface that gets closed off. Mm-hmm. In the case of applications where we are going to machine a part, we actually have them extend that cycle so that it drives that resin deeper and normally through the entire product, so that when we bring it back to do the machining operation, so if we were going to go in and do a turning operation to it, for instance, that resin helps alleviate some of the tool wear that we have during that cutting. So that resin is performed and impregnated into it to help us lubricate, not necessarily lubricate, but soften the cut of that.
And that would be dependent on the material, right? There are some materials we wouldn't necessarily need the resin to have that better machinability, but in some cases we need it.
We do need it in some cases, yes.
Okay.
It's certainly a help.
Okay. Joe, talk about thermal operations, maybe outside as a secondary.
You mean operation. As opposed to the steam treat?
As opposed to steam treat, right. Let's talk about other thermal operations.
Well, obviously there's external heat treat operations or annealing operations that may need done. There are some things that we do that change the characteristics of the part. So an annealing operation would have, or a tempering operation could exist on the product, and it's just putting that part back through another heating cycle to do that. And then to extend that, to go to a heat treat. For instance, if I can't necessarily use a cinder hardened grade of my material and get a heat treated part off my furnace because I need to do secondaries to it afterwards, like a machining operation, I may need to still do a post heat treat. And so we don't want to confuse our sintering operation as a heat treating operation. There's still the potential of doing a post-heat treat operation to those components where they'll heat that part up and do an oil quench normally of that product. So there is that version of that thermal operation that's also out there. So there's a number of things that can be done thermally that impact the part.
So really, to wrap it up, there are many different secondary operations out there, and it's really all dependent on, not only material, but what the usage of the part is, the function of the part, how it's being assembled, what part it's rubbing up against maybe or working against, you know, it may need different.
Yeah, if it's wear, if it's corrosion protection, there's a whole series of things that you do on that side. And then you've got the other secondaries that if it's a fitment thing or a surface smoothness, you get into the tumbling, grit blasting relation things of how it's going to go together.
Maybe even simply just cosmetic.
Or just cosmetic,
There's often parts that are just need a cosmetic finish as a secondary operation that's simply for cosmetic purposes.
Right.
So, okay.
Well,
listen, if you have any questions about different secondary operations or what might be a good fit for your part, you know, feel free to reach out to myself or reach out to Joe here at Atlas. We'd be happy to help you. We thank you for watching this episode of the PM Blend and would encourage you to subscribe to our socials. Thank you.